Assalamualaikum and hello everyone. Today my group wants to present about assignment. The topic of assignment is transistor bias circuit, and I will introduce about my group member. First group member is New Muhammad Hafiz bin Muhammad Razi AA212810. Second group member is Muhammad Samihi bin Yusuf AA205350. And third group member is Witness Victor Hontong AA210317. I will invite my friend that's Gates to explain about question 1.
Hi, my name is Nigix Victor Bontong and my matric number is AA210317. So I am from group 6 and I will be discussing about the design a CE amplifier with emitter stabilized bias. So for the first question, which is select a value of VCC and beta for the table 1. So since I am from group 6, I will be using the VCC equals to 25, the beta is 40, and the code for transistor is 2N3019. So for the second question, which is select a value of IC set is less than IC max. So for this question, I will be searching in the internet for the data sheet. So in this internet, this is the value of IC max, 150 milliamp. So the VCE max is 200 millivolt. So for the third question is select a value of ICQ is less than 1/2 of IC set. So after I calculate, the value of ICQ is equals to 75 milliamp. So for the fourth question, which is select a value for VC equals to 0.5 VCC, using the formula of VC equals to 0.5 times 25, which is the VCC, I will be getting 12.5 volt. So for the fifth question, which is let VE equals to 0.15 VCC, so after I calculate, I will be getting 3.75 volt. So for the sixth question, which is calculate RE, so after I calculate by using the formula of VE equals to IE times RE, the RE will be 6.1 ohm. So for the seventh question, which is calculate RC, and after I calculate all the calculation, and I will be getting RC equals to 280.67 ohm. For the eighth question, which is calculate IB. So after I calculate, I will be getting IB equals to 1.88 milliamp. And the last question, which is calculate RB, I will be using the formula of VCC minus VB minus VC equals to 0. And after I calculate the RB, I will be getting 2101.06 ohm, or we can call it 2.1 k ohm. So for this question, we need to show the simulation result by using software. So I will be using the Proteus, and after I run the Proteus, I will be getting the IB equals to 10.8 milliamp. But for the calculation, I will be getting the IB equals to 1.88 milliamp. It's different because the beta value is different from the simulation and also the calculation. That is all from me. Thank you.
My name is Muhammad Shamizi bin Yusuf and my number matrix is AA210350. And now I will continue with the second part, which is to create the design a CE amplifier with emitter stabilized bias. So for the question number 1 is to select a value for VCC and beta from the table 1. So from the table 1, I choose for the group number 6, which is the VCC is 25 and beta value is 40. And for the transistor chosen is for the code is 2N3019. And then so number question is select a value for IC saturation is less than or equal to IC max from the data sheet, which is this is the data sheet for the transistor. And here we can see how I get the value, and here is the answer, which is 100 milliampere in this at 1 1.0 is equal to 100 milliampere when I change it. So for number 3, the question is to select a value of ICQ less than or equal to 1/2 IC saturation, and this is the formula, and the answer is 50 milliampere. And for number 4 is to find the VC value, and the formula is 0.5 times VCC, and this is the answer, 12.5 volt. And for number 5 is to find the VE, and the formula given is 0.15 VCC, and so the answer is 3.75 volt. So to find the value RE, the question is to calculate the RE based on the value of VE and IE. So this is a basic formula, which is we use the VIR formula, and here is RE equal to VE over IE, because we already have the value. So the answer is 37.5 ohm. So to find the to calculate the RC value, next number 7 is and here I use the formula IC saturation equal to VCC over RC plus RE, and the answer I get here is 212.5 ohm. So for the next question is to calculate R2. Here is I use the formula, I implement the formula 0.1 beta RE, and the answer is 150 ohm. And the next question is to find the VB. So VB, we use the formula 0.7 plus with the VE value, and here the value is 4.45 volt. Yeah. And the last one is to calculate R1 based on the value of VB and R2. Here is the formula, R1 equal to R2 in a bracket VCC minus VB over VB, and after the calculation I got the value is 693 ohm. So from here to find the circuit, I use it in Proteus, and here is the circuit to find the value. Here is this is all the value, and this is the circuit for the question number 2. So I think that's all from me.
Thank you for Shamizi, because give me a chance to present. Okay, now I will present about conclusion. In conclusion, the CE amplifier with emitter stabilizer bias is a design that increases rigidity stability against changing external temperature by using an emitter resistor. We manually calculate the answer to question 1 and 2 before running a simulation in Proteus to verify the result. And we using the two techniques we have discovered to the solution. And that's all for me. Thank you.